Welcome back to Math with Miss Swartz. Today we're looking at quotient of powers. So we've been doing product of powers. We've reviewed a lot of that. And today we're going to zero in on some quotient rules. There's actually two of them that we're going to cover. One goes right along with what we are looking at with product of powers, so it won't change our idea of that very much. It'll flow right in, so it's not really new. The other one is pretty new, but we'll get a good understanding of it here. So we're going to start the way we started with a lot of these, is kind of getting an understanding. We're going to go over some of this, and for some of you, this could be in a journal, or you could just write it on your gold packet on like the back of something. Just quick, maybe do a couple of these and see how this works. So here we have a quotient with powers involved. So we have 2 to the 4th divided by 2 to the 2nd. So it wants us to write it out in repeated multiplication form or expanded form. So 2 to the 4th will look like 2 times 2 times 2 times 2 over 2 to the 2nd, which looks like 2 times 2. So what it wants us to give them is a power. Well, a couple ways we can think about this. One, if I'm dividing 2 divided by 2, they actually cancel. And if I'm dividing 2 divided by 2, they cancel. So what we are left with is 2 to the 2nd power. Okay, that's one way we could see it. 2 to the 4th power is also 2 times 2 is 4, times 2 is 8, times 2 is 16. And we're dividing that by 2 times 2, which is 4, which would give us 2 to the 2nd power, or 4. So you can see it in two different ways. Now, if you're looking at it in repeated multiplication form, we want to understand what the powers are, so we start to see a little bit of a pattern. So I'm going to write this next one out. We have negative 4 times negative 4 times negative 4 times negative 4 times negative 4 divided by, and then negative 4 to the 2nd power is negative 4 times negative 4. So if we're working this way, okay, if we separate them out, negative 4 divided by negative 4 is just 1. That cancels. So if you're not understanding why it cancels, think about what is negative 4 divided by negative 4. It's 1. Well, 1 times anything is that anything. So that doesn't really mean a lot to us, so we can just consider them canceled. So the same thing happens with those. So all we have left is negative 4 to the 3rd power. 3 negative 4s. So let's try this next one. 7 times 7 times 7 times 7 times 7 times 7 times 7. And then 7 times 7 times 7. Okay, so remember, we're looking for the pattern between the exponents over here and the exponents over here. So 7 divided by 7 is 1, 7 divided by 7 is 1, 7 divided by 7 is 1. We're left with 7 to the 4th. So you might start noticing a pattern, okay? 4 and 2 here, and we end up with 2. 5 and 2 here, we end up with 3. 7 and 3, we end up with 4. I'm going to jump down to these just to not have to write as much. 6, 7, 8. So cancel, 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 cancel. We're left with 10 to the 3rd. So maybe by now you've formulated an idea of the rule that we would have when we're working with quotient of powers. If you haven't, you can fill in some of the rest of these and maybe you start to see it after a while. But 4 minus 2 is 2. 5 minus 2 is 3. 7 minus 3 is 4. 8 minus 5 is 3. So if we had continued, okay, we would have 8.5 to the 3rd. We would have 3 to the 8th. Negative 5 to the 2nd. And 11 to the 3rd. We're subtracting our exponents. Okay, so here is your quotient of powers property. You can write this on your gold sheet. To divide powers with the same base, we're subtracting their exponents. So that goes kind of along with when you're multiplying powers with the same base, you add your exponents, the opposite. Just like multiplication and division is inverse, addition and subtraction is inverse. So there we go. So 4 to the 5th divided by 4 to the 2nd is going to be 4 to the 3rd. So this is kind of our newer one. And then we have one other one that we're going to look at here. It says, what happens when you find a power of a quotient? So this is like power of product. So we've looked at this where we had 3 times 2 to the second, and we were distributing the 2. So this is going to work very similar. So this is saying 2/3 squared. So what we have here is 2/3 times 2/3. And another way we could write that is 2 to the second power over 3 to the second power. So what we're doing is we are distributing the exponent into the top and the bottom, because if we wrote this out, 4 thirds times 4 thirds times 4 thirds, we would have 4 to the third power and 3 to the third power. So here we would have x to the third, 2 to the third, and a to the fourth, b to the fourth. So this can help us simplify. So here is another rule. This one you already know. You've already written that one down. And this one you might not have on your gold sheet, but you can add it closely under the quotient property. Okay. To find the power of a quotient, find the power of the numerator and the power of the denominator, and then divide. Okay, so this is something else we will see a little bit of. But this goes hand in hand with our property here. It works the same way. All right, we're on to some examples. So we have 2 to the 6th divided by 2 to the 4th. We have the same base, so our rule, we could either write out 6 2's and write out 4 2's and then see what cancels, or just know our rule, we would get 2 to the 2nd. -7 to the 9th divided by -7 to the 3rd. Know your rule, -7 to the 6th. And h to the 7th divided by h to the 6th would just give us h to the 1st, or h. Okay, so 9 to the 7th divided by 9 to the 4th would give us 9 to the 3rd. 4.2 to the 6th divided by 4.2 to the 5th give us 4.2. So go ahead and try 3 and 4. Should be pretty simple there. All right, so then we get into combining some of our properties that we've already learned. So we have 3 to the 4th times 3 to the 2nd divided by 3 to the 3rd. So just like we had to do before, we have to take care of our numerator before we can work on dividing. So I need to take care of my product rule here. My product rule says that if I have the same bases, I can add my exponents. So 4 plus 2 is 6, and then I'm going to keep my numerator the same. Now I can do my division, which gives me 3 to the 3rd. And if you wanted to simplify that, obviously that would be 27. So you're going to start to see some that have multiple properties included. Let's try this top one. Now we have a to the 10th divided by a to the 6th times a to the 7th divided by a to the 4th. Well, this is a little different than the last one. We need to take care of the division before we can multiply. So a to the 10th divided by a to the 6th would give us a to the 4th. Now I'll just write these in because I know they can be hard to see sometimes. So 10 minus 6 is 4 times a to the 3rd. 7 minus 4 is 3. Now we can multiply, and then we would add in that case, so we get a to the 7th. So I want you to go ahead and try this last problem. So you should have 3 problems that you have tried so far. All right, let's do a couple more of these, and then we'll try to wrap up here. So again, we need to take care of the piece that's not simplified yet before we can divide. So we got to simplify the denominator. 2 to the 3rd times 2 to the 5th. I'm going to add my exponents, 2 to the 8th, and then I can divide. So I'll subtract. So I would end up with 2 to the 7th. Now this looks different than this because now I'm going to have to divide first. So d to the 5th divided by d to the 1st would give me d to the 4th times d to the 9th divided by d to the 8th would give me just d. Then I can multiply, so d to the 5th by adding my exponents. So for your 4th problem that you're going to try number 7. All right, we're going to wrap it up there. We're not going to do these ones all together. You do have a worksheet that we will hand out, and we'll talk if we need to about anything. If you have questions, let me know. Have a wonderful day.